inverse of z by z minus a. Z inverse of z by z minus a. That is equal to 1 by z minus a. 1 by 1 z minus z raised to minus 1 means 1 by z. That 1 by z and this z will get cancelled. So it is z minus a. So now we are going to get, but here what we want? Here we want z plus a. Here we are having minus z minus a. To get z plus a, what we are going to do? We are going to multiply with a minus here. So minus a raised to n minus 1. Both the sides when we are multiplying with a minus, we will get minus a raised to n minus 1 u n minus 1 will give the z transform as 1 by z plus a. So here you can write it as minus a into minus a raised to n minus 1 u of n minus 1. That is, if you are solving, you can write it as minus a raised to here, minus a raised to 1 minus, okay, it will go. So you can write minus a raised to n u of n minus n. So this is how you can, so this is for n x of n. Now if you want, you are supposed to find x of n, no? So you can put this n here. So it is a by n into, so x of n will be equal to a by n minus a raised to n by n into u of n minus 1. This is the answer. So what we have found is, first we were given the question z transform, x of z was given as log of 1 plus a z inverse. So according applying our z differentiation property of z transform, we should have a term like this, or we will need a term, or we want a term like this. So first of all we will just differentiate. This term comes in the right side of the differentiation property, nxn gives z transform. So we will write so we will just differentiate dxz by dz and we got a term here. Now we are given with z transform and we want to find x of n. So what we will do? First we will find the equivalent or inverse of this and we found it as 1 by z plus a. Okay. So now we have multiplied both the sides by minus z. Here it was z raised to minus 2. When you have multiplied by both the sides by minus z, what you got? Here 1 minus 2 has reduced to minus 1 and now you got as this is equivalent to nx of n and nx of n is equivalent to this. Okay. Now we were having this inverse of this term here, that is z plus a we are having. Now we are going to apply the unit step function and time shifting property to this. So we know that unit step function is z by z minus a because we want to find the inverse z transform of z plus a. We want to find the inverse of that. So we know that step function is z by z minus 1. So we have scaled it by a factor a raised to n. That is time a raised to n u of n is equal to z by z minus a. That also we have already studied. Now we are going to have a shift in that. So when we are shifting it once, what will happen? We will get it as z raised to minus 1 z by z minus a. So that z raised to minus 1 and z will get cancelled, or naturally we are getting 1 by z plus a. This is what we want. So whatever we are getting here, we are going to substitute it and we got it. So these are the differentiations. See, in the one problem, when you are solving a problem, you can write different, or you can use different properties of z transform. Okay. Now let us move to the next one after a gap. Thank you.